Hi, time for another math easy solution. Today we're going to discuss limits at infinity and look at horizontal asymptotes. More on examples, but now look at part 3 of this example series. You can see all those videos that I did before in the video links below in the description. Well, let's go over this example. I'm just going to go over one example here, but this states find the horizontal and vertical asymptotes of the function, this one here, f of x equals square root 2x squared plus 1 all divided by 3x minus 5. Now the first step I'm going to go over vertical asymptotes, and to do this, well, vertical asymptote is when you have the function going to infinity when you have a certain value right here. It never reaches it, but it's going to it. And this is basically when you have a number divided by a 0. So we have to look at the denominator, and in this case we just set the denominator equal to 0. So it's when we set it equal to 0, 3x minus 5 is equal to 0, and then solving for x, we get x equals to 5 over 3. So this is the vertical asymptote, and so this function is not defined here, and as you get closer and closer to 5 over 3, you're getting closer and closer to this case right here, and this is basically going to infinity right here. But now to see whether it's going to be negative or positive infinity, we have to look at from both sides of 5 over 3. So we have to look at the limit as x approaches 5 over 3 from the left side of f of x, and then also to the right side. Let's go over this one first. So we put this negative meaning from the left side. So when we look at this function, it's going to equal to, well, basically, when we look at the top part, this is 2x squared plus 1 is always going to be positive. Any number you put in x squared becomes positive. Square root is still going to be positive. So we're going to have a positive number divided by, well, let's look at how the bottom is affected. So this 3x, if we have a number of x less than 5 over 3, for example, let's say 1 is less than 5 over 3, we're going to have 3 times 1 is 3, which is less than 5. So basically, any number here that's when we're approaching from negative 5 over 3, or from less than 5 over 3, this is going to be less than 5 right here. And then if we have a number less than 5, minusing 5, this is going to be, well, this is going to be less than 0 or negative. So this is going to be negative in this case. So then basically we're going to have a positive divided by a negative, but approaching infinity. So we're going to be basically, this is going to matter right here. So we're going to have it approach negative infinity right here. Or we could write limit, or just right over here, limit as x approaches 5 over 3 from the negative side of f of x equals to negative infinity. And now when we look at basically from the right side of it, or the positive side of, or put a plus here, of 5 over 3. This means the exact same thing now, where we have a plus number divided by, well, now this 3x minus 5. This 3x, now since we're approaching it from greater than 5 over 3, let's say 10. So 3 times 10 is 30. As you can see, it's greater than 5. Let's put greater than 5. Then a number greater than 5 minus 5 is always going to be greater than 0. And this is positive. So we're going to have a positive number divided by a positive number. Then we're just going to have the limit as positive infinity right here. So this is how the asymptote behaves, how the f(x) behaves near this asymptote of x equals to 5 over 3. And now let's look at horizontal asymptotes. And then for horizontal asymptote, we just have to look at the limits at infinity, or when x goes to positive or negative infinity of this function. So let's look at positive infinity first, and let's see if we get a limit or a horizontal asymptote. So limit as x approaches positive infinity of square root 2x squared plus 1 divided by 3x minus 5 right here. So now, as if you try to put in a positive infinity in this case, well, the top part is always greater than 0, so you're going to go approach infinity on the top, and on the bottom also 3 times, well, infinity, you're going to get to infinity. So we have this case right here, so you could apply L'Hopital's rule, or like I showed in my earlier video in part 2 of this example series, you could just times top and bottom by, well, or divide top and bottom by the highest power. In this case, is going to be x right here, because, well, I just have to make a note first. Square root of x squared, this just equals absolute value of x, because remember, this is always greater than 0. Now these roots, the square root and the 2 cancel out. But in this case, since we're approaching positive infinity, so let's just say it's really large and positive, it's the same thing, it's just having x, because it's still going to be absolute value. For example, 10 is going to equal to, well, absolute value of 10 is still 10. So we have this case right here. So now we could multiply top and bottom by the highest power. And I'll just write that down right here. So we're going to times by 1 over x, times by 1 over x, or divide by x on top and bottom, so we're not affecting anything because these cancel equals to 1. And now this part right here, we'll just write it as, well, 2x squared plus 1 times this by now 1 divided by square root x squared, because in this case this x is just equal to square root x squared, and we just change the top there. But the bottom, we could just leave it there. We can actually know, let's just divide it out inside each term. So we're going to get 3x over x minus 5 over x. And now we could actually bring this inside this function here, because this is just a square root. They're both square root. You could just put it inside. You can see more on this in power functions properties video in the video link below. So you can just put this x squared inside it, and you're going to have now limit as x approaches to infinity of square root, well, 2x squared divided by x. So we're bringing that x squared inside, plus 1 over x squared, and now all divided by 3. Now we just simplify this, 3 minus 5x, x is cancel, and now we can simplify this further, canceling the x squared. We're going to get limit as x approaches to infinity of square root 2 plus 1 over x squared, all divided by 3 minus 5 over x. So now we could basically apply, we'll just put really large number in x squared and in this x, and in both cases you're approaching infinity, you're approaching 0 on this top and 0 in here. So basically those are just 0, and we're just going to be left with, well, 2 over 3. Because basically these zeros are not going to do anything. You're just putting really large number, 1 divided by really large number is going to go to 0. So this is a horizontal asymptote. Or basically the line y equals to this is a horizontal asymptote. So now let's look at what happens when you approach to negative infinity, as x approaches negative infinity of this function right here. Now we're going to do the exact same thing as above, except now we have to change this part right here, because we did this initially for when it's positive infinity, square root x squared equals absolute value of x equals to x in this case, but it doesn't in this case, because we know that square root of x squared equals to absolute value of x. But now the absolute value of x, if all your x values are negative, we're just approaching negative infinity, so we're going to have negative x right here. For example, if you have, let's say, negative 10, then we're going to have the absolute value of it is just going to be, well, negative 10. This just equals to positive 10, and this equals to absolute value of 10. So this is, we have to have a negative for this case. So now we're going to do exact same thing as above. And now we're going to, instead of the, we're going to times top and bottom by 1 over x, but now the x doesn't equal to square root of x squared, but negative square root of x squared. So we do the same thing as writing negative square root x squared equals to x, and now we're going to be dividing by 1 divided by x, which x equals to negative square root x squared, and the bottom we don't change that, we just do 1 over x, we're just going to cancel this out. Remember, that's how it equals. So this is the exact same thing as above, except now we're having a negative sign. So this is, so exact same thing, but we have a negative sign right here. Yeah, so basically now we could just write the limit we got at the end of the first one, as positive infinity, but now we're just going to have this negative sign there. So we're going to have, we'll just write this one down right here, negative now square root 2 plus 1 over x squared, all divided by 3 minus 5 over x. So now the only difference is negative, and once again you plug this in, we're just going to get now negative square root 2 over 3. Yeah, so now we have horizontal asymptotes of, well, y is equal to plus or minus square root 2 over 3. These are horizontal asymptotes, and the x asymptote, the vertical asymptote is basically x equals to 5 over 3. And now I've graphed this with the Google graphing calculator, this function right here, the same one we just went over. And as you can see, there is a vertical asymptote at, well, 5 over 3. This is at x equals to 5 over 3. And there's horizontal asymptote right here. This is, the value of this is just square root 2 over 3. You could make sure by going on Google calculator and just calculating yourselves, etc. And then the bottom one here is exact same thing, but now there is a negative right here, negative square root 2 over 3. Yeah, and well, that's all for today. Hopefully you learned from this useful example on horizontal and vertical asymptotes. And remember, you could always download these notes in the Dropbox link below. And yeah, stay tuned for another math easy solution.